Welcome back to Analyst Bytes. In the last video, we covered the basics of the residual income model. Today, we are going to master the advanced stuff. We will look at two new scenarios. Number one, the persistence factor. Number two, when the exam gives you a specific relationship between price and book value. These are huge points for the exam. So let's cut the small talk and jump straight into the question. This question continues from our last video. Look at the yellow highlight. It says the analyst believes that a persistence factor of 0.1 is appropriate. This introduces a key concept, the persistence factor. We call it omega. What is omega? It measures a company's ability to keep making excess returns. It's usually between 0 and 1. If omega is close to 1, it implies that the company has a strong advantage or a moat. It's like this airplane. It can glide for a long time without landing. Think of a company like ASML. It is the only company in the world that makes the advanced machine needed for microchips. Every chip maker depends on their machines to survive, so they can enjoy high profits for a very long time. That is a high omega. But if omega is close to 0, it's like the heavy ball here. You throw it up, but it crashes to the ground instantly. These companies have no real advantage. Competition destroys their profits very quickly. Now picture the math in your head. 100 times 0.99 stays high for a long time, but 100 times 0.1 drops to almost 0 immediately. You might ask, why can't omega be bigger than 1? Because that means the company would grow faster than the economy forever. It would eventually buy the whole world. That's impossible, right? So omega stays between 0 and 1. Now let's look at the formula. It looks long and scary, right? Don't worry, I have a cheat code to help you remember it. Remember the GGM formula? The bottom part, the denominator, is RE minus G. Here, the growth rate of RI is negative. Let's call this negative growth G prime. We define omega as 1 plus G prime. So if we flip it around, G prime equals omega minus 1. Now let's put that into the GGM formula. Because of the negative signs, the bottom part simply becomes 1 plus RE minus omega. So you don't need to memorize the derivation. Just remember the final formula at the bottom. TV equals next year's RI divided by 1 minus omega plus RE. Now that we have the formula, let's crunch the numbers. First, we need the RIs for the first few years. I won't bore you with the detailed math for RI1, RI2, and RI3. We practiced this step by step in the last video. So if you feel lost, please go back and watch that one first. Just remember the base method we learned before. Calculate the book value, then the RI, then roll forward. It's simple. The real challenge is here. The question says from year 3, the persistence factor is 0.1. What does this mean? It means from year 3 onwards, the income starts to fade. Mathematically, it implies that RI4 will be RI3 times omega, and RI5 will be RI4 times omega, and so on. Understanding this makes the calculation easy. We can simply use our cheat code formula. We take the RI3 that we just calculated and put it on the top. We put our new denominator, which is RE minus G prime, or 1 minus omega plus RE on the bottom. Now, here is the most important part. Where does the terminal value sit on the timeline? Think back to the GGM model. We use the dividend from year 1 to get the value at year 0. The value is always 1 year before the cash flow. So, since we are using RI3 in our formula, the resulting terminal value sits at the end of year 2. It's TV2. Alright, we are at the final step. Let's finish the calculation. The process is exactly the same as before. Grab your calculator and go to the NPV and CF function. Input II1 into C01. For C02, remember we have both the RI2 and the TV2 we just calculated. So add them together and input the sum into C02. Press NPV, enter the discount rate I, press down arrow, and hit compute. The present value of all future II is 9.66. Finally, don't forget to add the initial book value. So the final value with a persistence factor of 0.1 is 54.91. Now problem solved, but let's take it one step further. Imagine you are in the exam hall. You're running out of time. Let's say you just calculated the value for the constant RI scenario in the previous question. Now the next question asks about a persistence factor of 0.1. Do you really need to calculate everything again to know if the value is higher or lower? No, you can use your intuition. Think back to our analogy. Constant RI means the persistence factor is 1. That's the airline. It flies forever. This scenario has a persistence factor of 0.1. That's the heavy ball. It drops quickly. Obviously, the airplane creates more excess value for shareholders than the falling ball. So without doing any math, you know the value in this question must be lower than the constant RI scenario. Sometimes logic is faster than a calculator. Finally, as always, let's wrap up with a recap. Number 1, the definition of omega. I want to emphasize this again. The persistence factor measures the ability to continue. It is not a decay rate. Therefore, it is strictly locked between 0 and 1. As long as omega exists, the residual income continues positively until it naturally fades away. Number 2, the big trap about that G prime. Please be very clear about this. G prime is just a memory aid I invented to help you memorize the formula. On the real exam, if you see a growth rate G, it usually refers to the earnings or dividends. It's absolutely not this G prime. So never see a G and try to work backwards to find omega. That's a huge mistake. There is only one rule. Only use our special formula when you explicitly see the words persistence factor in the question. That formula is TV equals RI divided by 1 minus omega plus RE. Number 3, the final check. After you calculate the present value, do not forget to add the initial book value. We practiced this in the last video, so I won't repeat the steps. Just keep this in the back of your mind every time that you solve a RI-related valuation problem. Okay, we have finally arrived at the last type of RI question. It might be a bit abstract, but hang in there, this is the final hurdle. Once we clear this, you might officially master the RI model. This question looks completely different from the others. Let's ignore the complex numbers on the left for a second. Please look at the little cake on the right. It's not just for decoration. It perfectly explains the logic of this problem. There is one key sentence in the question. The stock will trade at a 20% premium over its book value at the end of year 3. So what does this have to do with the terminal value? Let's break down the cake model at the end of year N. Imagine taking a snapshot at that future moment. The brown base, this is the shareholders' investment book value at year N, the BN. The pink cream on the top, this represents all future residual income after year N, discounted back to this moment. That's our terminal value, TVN, the whole cake. This is the total projected value of the company at that specific time, the stock price, PN. Now look at the logic. Since the question gives us the relationship between the total price and the base, calculating the pink cream becomes very simple. We just take the whole cake, PN, subtract the base, BN, and what's left is the cream, TBN. Look at the yellow formula at the bottom. Since price equals book value plus TV, we can simply rearrange it. TV equals price minus book value. Logic solved, formula solved. This is much easier than discounting II line by line, right? However, I must add one crucial condition. For this logic to work, we actually assume the market is efficient at the future date. In other words, the company must be fair valued. Only when price equals intrinsic value can we use the market price to solve for TVN. All right, theory is done. Let's look at the actual numbers. First, let's calculate the II. Notice something. This question doesn't give you EPS or DPS. It gives you ROE. Don't panic, just use the standard II definition. II equals ROE minus RE times the beginning book value B0. Use the first year's ROE minus RE times B0. Easy, we get II1, which is 1.6. Now here is the tricky part. How do we get II2? We still need book value at year 1. Do not use the long base method here. It's too slow. Look at this sentence. All earnings are reinvested. This means dividends are 0. Here is a speed tip. When dividends are 0, the book value simply grows at the rate of ROE. It is compounding. So B1 is just B0 times 1 plus ROE. And B2 is B1 times 1 plus ROE squared. Master this rule and you will be twice as fast on your calculation. So now we have II1, II2, and II3. Let me ask you, do we need to calculate B3? Yes, we do. The terminal value is based on the book value at year 3. So here is B3. Now we can calculate the terminal value. Please open your eyes. This is a huge trap here. In the previous models, the TV calculation usually shifts back 1 year. But in the premium model, everything is instant. The question gives us the premium at the end of year 3. So TV3 equals P3 minus B3. Think of the timeline. TV, price, and book value, they are all at time 3. No shifting back. Finally, here is a little math magic. The problem says P3 is at a 20% premium. That means P3 equals 1.2 times B3. Let's put that into the formula. 1.2 B3 minus B3 equals 20% times B3. See, you just need to take the B3 you calculated and multiply it by 0.2. Snap! Your TV3 is 6.572. Done! Alright, the final step, calculating V0. Let's load the calculator. For C01, enter the value of II1. For C02, enter the value of II2. Now C03 is the critical one. At the end of year 3, we have the terminal value we just found it, plus the II for that year. Don't forget to bundle them together. So C03 is a sum of TV3 and II3. Press NPV, enter I equals 10, and hit compute. Now we have the NPV number. Then add the initial book value B0. And there you have it. The final value B0 is 29.49. Let's wrap up with 3 key takeaways for the premium scenario. Number 1, if you see a premium question, smile. The CFA Institute is actually being nice to you. It is the easiest calculation. Just price minus book value. The only trap is the timeline. TV and price are in the same year. Unlike the GGM model, there is no shifting back. So when discounting, make sure to bundle it with that year's II. Number 2, a logical extension. What if the question says price equals book value? That means P minus B is 0, so TV is 0. This implies no more excess returns. This perfectly matches the omega equals 0 scenario we discussed it earlier. The logic is a complete circle. Number 3, don't be lazy. When calculating terminal value, you must calculate the future book value for that specific year. Never try to use the initial B0 to save time. That will make your answer completely wrong. Okay, we have officially covered every single complex formula in the residual income chapter over these 2 videos. But remember, hearing it is one thing, doing it is another. I strongly suggest you grab a pen and paper and actually solve these examples yourself. You only truly master it when you physically press the buttons and see where you get stuck. That is how you secure these points. Now for the ultimate summary. I have put every formula and the scenario onto this one page. Feel free to take a screenshot. Now let's do a 30-second speed run through this formula map. For multi-stage models, Scenario 1, constant II. This means the persistent factor omega is 1. This is the easiest. Just use the standard perpetuity model. TVN minus 1 equals IIN divided by RE. Scenario 2, decaying II. The questions gives you a specific omega, like 0.1 or 0.6. Don't overthink it. Just use our modified GGM formula. Remember the denominator? It's RE minus G prime, or 1 minus omega plus RE. Scenario 3, premium. This implies omega is not 0. There is still future value. We might not know the exact path of the decline, but the result is simple. TV equals P minus B. Scenario 4, price returns to book value. This is the quickest one. It means II has hit 0. This matches the omega equals 0 scenario, so TV is 0. Finally, at the bottom, the single-stage model. Don't let the name scare you. It is essentially the Golden Girls model, just with the II1 instead of D1. One final nagging reminder. No matter which scenario you use, when you calculate all the present values, use your calculator's CF and NPV function. Never ever forget to add the initial book value B0. Okay, that covers everything you need to know about II formula. We finally cracked the hardest nut, the II model. Give yourselves a round of applause. You guys are amazing. Is your brain feeling a bit fried? Don't worry. In the next video, we are going to switch gears. We will do something lighter but super practical. We are going to revisit a classic topic from CFA Level 1 equity. It is often confused, but it's actually very interesting. It's the index weighting method. This time, we are saying no to boring textbook data. We are going to the real world. We will analyze the giants you know best: Apple, Goldman Sachs, Nvidia, and so on. We will decode the news. When you hear the Dow is up or the S&P is down, how is that actually calculated? And here is the best part. I will show you a shocking counterintuitive truth. Apple is a $3 trillion giant. Goldman Sachs is much, much smaller. Yet in Dow Jones Index, Apple matters less than Goldman Sachs. Why? The math behind this might be the complete opposite of what you imagine. So if you want to see how the real market works, or if you are a level 1 student, don't forget to hit subscribe. You don't want to miss this. I will see you in the next video. Bye!